Hello everyone, this is Dr. Lennon, and I wanted to walk you through problem number 5 on this Mind-Tap Chapter 11 for linear optimization of this credit union that's making different types of loans to its members. So essentially what's going on is we have these expected rate of returns for all of these types of investments, and we have a variety of constraints affecting them. So we have 8%, 10%, 11%, 12%, and 9%. So the first thing I did was I just copied that table into the sheet where we have the type of loan and the return. Well, let me restart this because I've already done the optimization. So essentially what I've created here is I've created just variables for each of the loans, because essentially what we're going to do is we're going to see how can we optimize this this investment portfolio so that we meet the number of constraints that they have. So if we back up off the formulas, essentially what I've done here is so right now I've got the 5 variables for the 5 different ways that we can invest the money, and then I also just put in dummy values to start, 1 for each one before we apply the solver, and then I created a percent of the total because a variety of the constraints deal with the percentages involved. So if you look at the formulas, the percentages, so the sum invested is just the sum of these 5 values, and then the percent is each of the respective values. So for auto, currently it's 1, so cell B10 is being divided by B16, the sum, and that's the case for each of the 5 categories, so that gives the percentage. Okay, so these 3 cells right here, these are actually constraints. So let me maybe I can move these or insert to note that they're actually constraint variables. So the constraints are given below. Let me see if I can insert a few lines there just to clear this up a little bit. And then maybe what I'll do is I'll move this return up here so it looks a little neater so we can kind of understand what's going on. So the sum invested is just the sum of the total investments, and then the return, the way we compute the return is that is the sum product of each of the return values with each of the investments. So for instance, the return is the number of dollars that you invest in auto times the 8% return plus the number of dollars you invest in these furniture loans times the return on that category, and so on and so forth for each of the 5 categories. So essentially what this is doing is B2 times B10 plus B3 times B11 plus B4 times B12 plus B5 times B13 plus B6 times B14. So that's what's going on there. So then let's look back at the problem to see the constraints. So we have some kind of tricky constraints. So it says there's $2 million to invest. So that means that your sum total has to be less than or equal to $2 million. Then it says risk-free securities may not exceed 30% of the available funds. So that's why I set up the percent categories. So there we're going to say, okay, the risk-free has to be less than 0.3. And the signature loans may not exceed 10% of the funds invested in all loans. So this was the part, actually, I was stuck on this problem for quite a bit of time, and I'll tell you why. The reason is I said, okay, that's got to be less than 0.1, but that's not the case. It's less than 10% of the funds invested in all loans. And you say, well, that's everything, right? Well, notice in parentheses here it says automobile, furniture, other, and signature. The first 4 categories are loans, and the last one is risk-free securities, which is technically not a loan. So if you were doing the problem setting it less than 0.1, your constraint's going to be messed up. So because of that one right here, I created this column 10% of other loans. That's one of the constraints. So that's 0.1 plus the values from the first 4 variables, but not including this risk-free variable. So that's one of the key constraints. And then the 2 others, it says furniture plus other may not exceed automobile, so I created other plus signature here and also other plus furniture. So other plus furniture has to be less than auto, and other plus signature has to be less than risk-free. So those are going to give the constraints. So we have 2 million total, and then we have 4 more. So we should have 5 total constraints when we run the solver optimization. And the other thing I will tell you is because the percentages are being divided by the sum of the variables, again, I couldn't make this work with simple linear simplex, so I had to use the nonlinear step. There's probably a way to make it work in a linear setting, but for me it's just easier to compute the percentages this way. So let's take a look at the solver then. So go up to data and click the solver. And yeah, so we want to maximize the return. Our variable cells are B10, 11, 12, 13, and 14. So those are the ones right here. And then we have each of the constraints. We want B13 less than or equal to B20. So the signature has to be less than or equal to 10% of all the other loans. B14 has to be less than or equal to 600,000. You could have also done, so I did B14, the risk-free, it said it had to be less than 30% of the total investment. So what you can do is you can do the amount of money invested has to be less than or equal to 600,000. That's 30% of the total 2 million. Or what you could have done is you could have taken C14 right here and put that less than or equal to just the 0.3 if you would have liked to have done that instead. All right, B16, the sum invested, this dollar number has to be less than or equal to the 2 million. B21, so that's this constraint, other plus signature must be less than or equal to C14, which is the risk-free percentage. And B22, other plus furniture, needs to be less than or equal to C10, the auto percentage invested. Okay, then like I said, I mean, I'll show you if I try the simplex linear, I'll hit solve and I'll get an error. See, it won't give me any solution. And it's because I'm using the percentages as a formula dividing by the sum, I'm pretty sure. But if we do it with a GRG nonlinear, then we'll still get all the correct solutions. So we got the optimized solutions. So let's go ahead and just plug in the values and make sure that they work. So maybe I can move this on the other half of the page. Okay, fund allocation. What did we get? 630, 123. Furniture allocation, 170000. Next one, 460000. 140000 and 600000, and then the return is 188800. So let's check that out, and hopefully, yep, everything went according to plan. So we're all set there. So let me know if you have any other problems with this one. Like I said, the key for me was recognizing that these 4 categories you don't include risk-free. And also that, the way I set it up, dividing with the percentages, nonlinear was the route to go, which is what we'll be looking at next module anyway. So good luck on the rest of the homework.